Exercise 2.07. Prepare simple twist joints.
Dear student, at the end of this exercise, you will be able to mark the length of insulation to be removed. In the insulation, prepare a straight twist joint in copper and aluminium. Prepare a rat tail joint in copper and aluminium.
Requirements: tools and instruments. Wireman's toolkit, 1 set. Steel rule, 300 mm. Diagonal cutting pliers. Materials: PVC insulated copper cable, 1 by 1.12, 2 meters. Cotton cloth. Sandpaper, smooth. Procedure: Task 1. Make a straight twist joint. 1. Collect 2 pieces of 1 by 1.12 PVC copper cable of 0.5 meter length. 2. Straighten the cables. 3. Mark 80 mm length on one end of each piece of cable. 4. Use the knife at an angle of 20 degrees and remove the insulation from each conductor for a distance of 80 mm. Avoid nicks in the conductor. 5. Clean the ends with the help of cotton cloth. Use smooth sandpaper if necessary to clean the conductor. 6. Place the conductors together, about 50 mm from the ends. 7. Twist them tightly round each other in the opposite direction. Each twist should contain about 6 turns. Each turn of a conductor should fit closely to the adjacent turn. Eight. Cut off the excess length of the conductor with side cutters. 9. Press the sharp edge of the conductor end and smooth it. 10. Repeat the steps 3 to 9 and make a few more joints for practice. Task 2. Make a rat tail joint. 1. Collect 2 pieces of 1 by 1.2 mm PVC copper cable of 0.5 meter length. 2. Straighten the cable. 3. Mark and skin both the cable ends for 50 mm. 4. Clean the conductor ends with the help of cotton cloth and emery paper. 5. Cross the bare wires at an angle of 90 degrees, at a distance of 45 mm from the cable end. 6. Tightly twist the ends. Remember, the twist on the wire should be uniform and close. 7. Make at least 6 twists. 8. Fold the remaining wire back on the twists. 9. Cut the excess wire. 9. Press the ends of the wire with the help of combination pliers to avoid sharp ends. Skill sequence 1. Prepare married joint in stranded conductors.
Dear students, this lesson will help you to prepare a married joint in multi-strand conductors.
Requirements: tools and instruments. Wireman's hand toolkit, 1 set. Diagonal cutting pliers, 150 millimeters. Steel rule, 300 millimeters. Materials: PVC insulated copper cable, 7 by 0.914 of 660 volt grade, 1 meter. Cotton cloth. Sandpaper, smooth, 1 sheet. Procedure. Task 1. Prepare a married joint in 7 by 0.914 stranded conductors. 1. Collect 2 pieces of PVC insulated copper cable, 7 by 0.914 of length 0.5 meters. 2. Mark both cables at 120 millimeters from the cable ends. 3. Remove the insulation for 120 millimeters on both the cables. Care should be taken while removing the insulation. Do not nick or shave the conductor. 4. Open the strands up to 50 millimeters from the cable insulation. Clean the strands with sandpaper and cotton cloth. 5. Cut the center strand of both cables close to the twist, about 70 millimeters from the free end. 6. Make a binding on the twisted part of both the cables. 7. Interlace the strands, keeping the center butt. 8. Hold one of the cables in one hand and twist the strands of the other cable end over it, one by one, closely and tightly. In doing so, each strand has to be twisted half a turn at a time. Twist the strands of the other cable one by one. The direction to twist from the shoulder should be the same as the cable's original twist direction. Cut the ends with a diagonal cutting pliers. 9. Remove the binding made at step 6. Complete the joint by rounding off the twisted strands with pliers. Exercise 2.08. Prepare T-joint in stranded conductors.
Dear students, at the end of this exercise, you will be able to prepare a T-joint in multi-strand conductors.
Requirements: tools and instruments. Wireman's hand toolkit, 1 set. Steel rule, 300 millimeters. Diagonal cutting pliers, 150 millimeters. Materials: PVC insulated copper cable, 7 by 0.91 of 660 volt grade, having length 0.5 meters. 2 pieces. Cotton cloth. Sandpaper, smooth. Procedure. Task 1. T-joint in stranded copper conductor. 1. Collect 2 pieces of PVC insulated stranded copper cable, 7 by 0.91. Indicate one piece as through cable and the other one as tap cable. 2. Mark the point of tap in the through cable. Mark 60 millimeters on either side at the point of tap. 3. Remove 60 mm insulation on either side of the through cable from the point of the tap. Do not nick or shave the conductor while removing the insulation. 4. Mark 180 mm at the end of the tap cable. Remove the insulation. 5. Open the strands of the tap cable and clean them. Use smooth 00 sandpaper if necessary. 6. Retwist the strands in the original direction. Make a binding on the twisted part of the tap cable, up to 50 mm from the insulation. 7. Untwist the through cable to provide an opening at the point of tap. 8. Insert the center strand of the tap cable in the opening of the through cable. 9. Wrap 3 strands of the tap cable around the through cable on either side of the tap point to form a shoulder on the through cable. 10. Wrap the strands to the end and trim off the end of the strands. 11. Remove the binding from the tap cable. Wrap the center strand of the tap cable around the through cable and wrap it in the place of the binding. 12. Round up the ends with a combination of pliers or mallet to avoid sharp edges of the strands. Skill Sequence 1. Prepare joints in solid copper conductors.
Dear students, this lesson will help you to prepare the Britannia straight joint in the given solid copper conductor. Prepare a Britannia T joint in solid copper conductors. Prepare a Western Union joint.
Requirements: tools and instruments. Wireman's hand toolkit, 1 set. Steel rule, 300 mm. Diagonal cutting pliers, 150 mm. Hand vise. Mallet with 75 mm diameter head. Materials: hard drawn bare copper wire, 4 mm diameter and 0.3 meters long. 2 numbers. Annealed copper, 4 mm diameter and 0.3 meters long. 2 numbers. Tinned copper wire of diameter 0.914 millimeters, 4 meters. Sandpaper, smooth. Cotton cloth. Procedure: Task 1. Britannia straight joint. 1. Collect 2 pieces of 4 mm diameter hard drawn bare copper wire, 0.3 meters long. 2. Straighten the conductors using a mallet. The 2 pieces should be free from twist over the entire length of the joint. And clean them using fine sandpaper and cotton cloth. 3. Bend each piece at one end for about 20 millimeters in length at an angle of 90 degrees. 4. Collect the binding wire and straighten it without any nicks. 5. Hold the two ends of the bare copper wire to be joined in the hand vise. 6. Form a loop of binding wire, leaving one end, about 250 millimeters, at the right-hand side of the joint. Place the binding wire in the groove formed in between the main conductors. 7. Start binding the wire tightly over the joint from position A and continue till position B. 8. Insert the free end of the wire inside the loop. 9. Grip the 250 millimeter loose end of wire with pliers and carefully pull it so that the loop and the free end of the wire pulled inside the wrapped joint. 10. Wrap the free end and the loose end over the conductors. Cut the ends with cutting pliers. 11. Press the ends of the binding wire with pliers to the conductors. 12. Smooth the sharp edges of the protruding wire ends with a flat file. Task 2. Britannia T joint. 1. Collect two pieces of 4 mm diameter hard-drawn bare copper wire, 0.3 meters long each. 2. Straighten the conductors using a mallet and clean them with fine sandpaper and cotton cloth. 3. Bend and shape one of the conductors according to the size with the help of combination pliers. 4. Straighten the 0.914 mm diameter binding wire. 5. Hold the two copper conductors to be joined with the help of a hand vise. 6. Form a loop of binding wire, leaving one end about 250 millimeters at the right side of the joint. Place the binding wire in the groove formed in between the conductors. 7. Start binding the wire tightly over the joint from position A and continue till position B. 8. Insert the free end of the wire inside the loop. 9. Grip the 250 millimeter loose end of the wire with pliers and carefully pull it so that the loop and the free end of the wire go inside the joint. 10. Wrap the free end and the loose end over the conductors. Cut the ends with cutting pliers. 11. Press the ends of the binding wire with pliers to the conductors. 12. Smoothen the sharp edges of the protruding wire ends with a flat file. Task 3. Western Union Joint. 1. Collect 2 pieces of annealed bare copper conductor of 4 mm diameter and of length 30 cm each. 2. Straighten the conductor with a mallet. 3. Mark and bend both the conductors. 4. Clean both the conductors with smooth sandpaper. 5. Hold the conductors in the vise. 6. Wrap one conductor over the other conductor by using combination pliers. 7. Make at least 5 turns. 7. Repeat the same procedure in the other end of the conductor, but wrap the conductor in the opposite direction. 9. Press the ends with pliers to the conductors. Smoothen the ends of the conductors with a flat file to avoid sharp edges.
Dear students, we have successfully completed the first part of basic electrical joints and fittings. See you again in the next part. Thank you.
Basic Electrical Training, Sector Electrical, for modular employable skills.
My dear students, all the exercise we are going to see is from Basic Electrical Training, Sector Electrical, for modular employable skills. So, please listen carefully and observe it. It will be very useful for you to understand and to implement in your workplaces. So, please do watch carefully again. Thank you.
Exercise 1. Practice safe method, lifting and handling.
Dear students, in this exercise, you are going to learn about the practice of safe method, lifting and handling heavy equipments. At the end of this exercise, you shall be able to demonstrate how to lift and handle heavy objects during working conditions, such as lifting from floor, during lift, carrying, lowering to bench, lifting from bench, lowering to floor.
Requirements: tools and equipment. Single phase 1 HP 240 volt 50 Hz capacitor start induction motor 1 number. DE spanner set 5 mm to 20 mm set of 8, one number. Workbench or table, one number. Procedure: switch off the motor and remove the fuse carriers. Ensure the equipment is disconnected from supply and the base plate nuts of the motor have been removed. Make sure of the position where the equipment is to be placed. Position yourself near the equipment for lifting. Lift the equipment from the floor using the correct posture. Carry the equipment to the workbench safely, keeping the equipment close to the body. Keep the equipment carefully on the bench and adjust its position correctly. Assume the overhauling work is over and the motor to be placed in its original place. Lift the equipment correctly with a firm grip. Carry the equipment to the original place. Lower the equipment safely with your feet apart.
So students, I hope you have learnt how to lift heavy objects without causing injuries to yourself.
Exercise 2. Practice safe method.
Dear students, in this exercise, we will deal how to rescue a person from live wires and to give a different type of first aid methods to the affected person.
Rescue a person from live wires.
At the end of this exercise, you shall be able to rescue a person from live wire, apply respiratory methods.
Artificial respiration. Nelson's arm lift back pressure method. Place the victim prone. That is, face down with his arms folded with the palms, one over the other. And the head resting on his cheek over the palms. Kneel on one or both knees near the victim's hand. Place your hands on the victim's back beyond the line of the armpits. With your fingers spread outwards and downwards, thumbs just touching each other. Gently rock forward, keeping the arms straight until they are nearly vertical, and thus steadily pressing victim's back to force the air out of the victim's lung. Artificial respiration, Scapper's method. Lay the victim on his belly, one arm extended directly forward. other arm bent at the elbow and with the face turned sideward. Kneel astride the victim so that his thighs are between your knees, and with your fingers and thumbs positioned. With the arms held straight, swing forward slowly so that the weight of your body gradually brought to bear upon the lower ribs of the victim to force the air out of the victim's lung. After 2 seconds, swing forward again and repeat the cycle 12 to 15 times a minute. Artificial respiration, mouth-to-mouth method. Lay the victim flat on his back and place a roll of clothing under his shoulders. Ensure that his head is thrown well back. Tilt the victim's head back so that the chin points straight upward. Grasp the victim's jaw and rise it upward until the lower teeth are higher than the upper teeth. Or place fingers on both sides of the jaw near the earlobes and pull upward. Maintain the jaw position throughout the artificial respiration to prevent the tongue from blocking the air passage. Take a deep breath and place your mouth over the victim's mouth. Repeat this 15 times at the rate of at least once per second. Artificial respiration, mouth to nose method. If the victim's mouth will not open or has a blockage you cannot clear, use the finger of one hand to keep the victim's lips firmly shut. Seal your lips around the victim's nostrils and breathe into him. Check to see if the victim's chest is rising and falling. Cardiac arrest. In cases where the heart has stopped breathing. Immediately. Quick action is essential. Lay the victim on his back on a firm surface. Kneel alongside, facing the chest, and locate the lower part of the breastbone. Place the palm of one hand on the center of the lower part of the breastbone, keeping your fingers off the ribs. Cover the palm with your other hand and lock your fingers together. Keeping your arm straight, press sharply down on the lower part of the breastbone. Then release the pressure. Repeat this 15 times at the rate of at least once per second.
Dear students, this is a very important exercise since this saves life with your proper first aid.
Exercise 3. Prepare terminations. Skinning cable ends.
Yes, students, in this exercise we will demonstrate how to skin different types of cable ends with the proper tools for the skinning. At the end of this exercise, you shall be able to skin the insulation of cables using a knife without causing nicking to the conductor, manual stripper and a wire stripper with auto ejection of insulation. Strip off the insulation of the PVC sheeted cable using the knife. Strip off the insulation of the PVC sheeted cable using side cutting pliers.
Requirements: tools and instruments. Wireman's toolkit 1 set. Wire stripper, manual and auto, 1 each. Diagonal cutting pliers, 150 mm, 1 number. Procedure. Task 1. Skin the cable insulation using a knife. Mark the length of 1.5 square millimeter cable at 400 mm from its end. Cut the cable using a combination pliers at the mark. Mark the length of the insulation to be skinned from either end. Check the sharpness of the knife blade and resharpen if necessary. Remove the insulation of the cable for about 10 mm at its end using a knife. Keep the knife blade at an angle of about 20 to the cable. Check there is no nicking over the conductor. Task 2. Skin the cable insulation using a manual stripper. Mark and cut the length of the cable to the trimmed off. Straighten the ends at which insulation is to be skinned. Mark the point from which the insulation is to be skinned. Adjust the jaws of the manual stripper and set them to suit the gap equivalent to the size of the conductor core. Set the jaws at the mark. Press the handle of the stripper and turn to cut the insulation. Pull the stripper to remove the insulation. Task 3. Skin the cable insulation using an auto stripper. Mark the length of insulation to be removed from the ends. Straighten the cable ends. Study the stripper and its working. Select a slot in the jaws whose diameter is equal to the conductor core diameter. Locate the jaws of the stripper exactly at the mark. Press the stripper. Further pressing makes the required length of insulation cut from the cable end. Task 4. Skin the insulation of 3 or 4 core cable. Mark out the length up to which the insulation has to be removed from the cable. Place the knife on the marking to which the sheath or insulation of the cable has to be removed. And in a circular motion, cut the insulation around the cable to a depth of approximately 3/4 of the thickness of the sheath or insulation. And with the knife, slit open the sheath or insulation between the circular cut.
Students, hope you have learned the skinning of the cable ends very well.
Exercise 4. Prepare terminations, crimping cable ends.
Dear students, in this exercise, you will come to know how to fix the lug, the cable ends, which is nothing but crimping of cable ends. At the end of this exercise, you shall be able to skim the cable end, select the crimping lug that suits the wire size and the terminal size. Select the crimping pliers that match the selected crimping lug size. Use the crimping pliers to crimp the lug at the cable end. Use an eyelet crimping pliers to prepare eyelet terminations.
Requirements: tools and instruments. Wire stripper, that is manual, 200 mm, one number. Crimping pliers, 150 and 200 mm, one number. Wire stripper, auto eject or manual, 200 mm, one number. Steel rule, 300 mm, one number. Side cutting pliers, 150 mm, one number. Eyelet crimping, that is closing pliers, 200 mm with former 4 eyelets having inner dia of 3, 4, 5, 6 and 7 mm, one number. Procedure. Task 1. Crimping of lug connector. Collect the cable, that is fine multi-strand copper conductor. Collect the spade connector suitable to the core thickness and terminal size of 6 mm dia. Twist the strands of the wire lightly in the same direction as in the original. Select the crimping pliers that matches with the terminal size. Clamp the spade connector with the crimping pliers in the matching position of jars. Apply sufficient pressure in the handle of the crimping pliers to press the lug connector fully.
Dear students, you might have known how to fix the lug at the cable ends.
Exercise 5. Solder joints, lugs, sleeves, ferrules in copper, aluminum cable.
In this exercise, you will know the importance of soldering and how it can be carried out. At the end of this exercise, you shall be able to solder copper conductor joints using a soldering iron and resin coat solder. Solder a lug in a copper cable with the help of a blow lamp. Make sleeve or ferrule joints in copper cables by the pot and ladle method. Solder a lug to an aluminium cable. Make a ferrule joint in an aluminium cable. Make a sleeve joint in an aluminium cable.
Requirements: tools and instruments. Wireman's hand tool kit, 1 set. Steel rule of 300 mm, 1 number. Diagonal cutting pliers, 150 mm, 1 number. Electric soldering iron of 60 watts, 250 volts and 50 hertz, 1 number. Blow lamp of 1 liter capacity, 1 number. Tongs 300 millimeter, 1 number. Sheet steel tray 150 into 150 into 20 millimeter, 1 number. Pot and ladle, 1 set. Tripod stand, 1 number. File, that is flat bastard, 150 millimeter, 1 number. Procedure. Task 1. Solder copper conductor joints. Select a 60 watts 250 volt AC 50 Hz soldering iron and ensure that the iron has no physical damage. Check the bit to see whether the surface is smooth and clean. When the bit becomes sufficiently hot, apply a small quantity of resin coated solder and tin the bit. Keep the soldering iron bit on the joint and heat it for soldering. When the joint is heated, keep the resin coated solder on the joint and allow it to melt. Use a cotton cloth to wipe off the excess solder from the surface of the joint. When it is still hot, allow the joint to cool naturally. Do not blow air for cooling. Task 2. Solder a lug to a copper conductor. Collect 30 amps cable lug. Copper cable 7 bar 1.06 or 7 bar 0.914, that is 6 square millimeter of 250 millimeter length. Blue lamp. Matchbox. Cotton cloth. Solder stick. Tray. And flux. Clean the inner and outer surfaces of the 30 amps cable. Add about 2 mm to the marking. Remove the insulation from the cable and clean the strands. Wrap a cloth or cotton tape on the insulation of the cable to a length of 30 mm and wet it with water. Light the blue lamp and let it emit a blue flame. Apply a thin coat of flux to the cable end. Tin the cable end by monitoring the blue lamp on the solder stick. Apply a small quantity of flux inside the lug socket. Tin the lug by melting solder stick to fill the socket and pour the molten solder in the tray. Apply some flux to the cable end and socket interior. Fill up the socket of the lug with molten solder. Monitor the blow lamp flame on the socket. Insert the cable in the socket and hold the cable vertically. Remove the blow lamp and hold the cable and socket without shaking. Task 3. Solder a ferrule or sleeve to copper cable. Collect 2 pieces of 7 bar 1.06 or 7.0.914 copper cable. Remove the insulation from the cable and clean the strands. Clean the inner and outer surfaces of the 30 amps cable. Melt solder, that is a blow lamp, also could be used. Put some flux in the molten solder and remove the slag from the top surface by the ladle. Apply some flux inside the ferrule. Apply a small quantity of flux on the cable ends. Place a prepared cable and tin it by pouring molten solder on it with the help of the ladle. Tin both of the cable ends. Insert the tinned cable ends in the ferrule such that only 6 mm back conductor is seen outside. Keep the joint over the tray and pour molten solder over the joint with the help of the ladle so that the molten solder gets inside the ferrule through the gap. Hold the jointed cables without shaking and allow the solder joint to cool.
Dear students, you might have known how to solder a copper conductor joints, solder a lug to a copper conductor, solder a ferrule, sleeve to copper cables, and also in aluminium.
Exercise 6. Determine the relationship between V, I and R, that is voltage, current and resistance in a DC circuit.
My dear students, in this exercise we are going to learn about the circuits and to determine the relationship between voltage, current and resistance. At the end of this exercise, you shall be able to connect the voltmeter in the circuit, read the voltmeter, connect the ammeter in the circuit, read the ammeter, connect the circuit elements in series, test the electrical continuity.
Requirements: tools and instruments. Ammeter 0 to 500 milliamp, one number. Ammeter 0 to 1 amp, one number. Voltmeter 0 to 15 volt, one number. Equipment and machines. 6 volts battery, 30 Ah capacity OR, one number. DC variable power supply 0 to 30 volt 2 amperes, one number. Rheostat of 20 ohms 3.7 amps, one number. Procedure: relation between voltage, current and resistance. Voltage variable and resistance constant. Connect the circuit elements. Ascertain the value of each major division and minor division of the scales. Apply different voltages by varying the rheostat arm of the potential divider in succession across the resistance. Measure the voltage and corresponding current from the instruments. Record the measured values in Table 1.
So my dear students, you might have known how to read and connect voltmeter, ammeter and circuit elements in service.
Exercise 7. Group different wattage lamps in series.
Dear students, in this exercise you will come to know how to group different wattage lamp in series. At the end of this exercise, you shall be able to read and interpret the data stamped on a given lamp, measure the voltage drop across the lamp when unequal wattage lamps are connected in series to the supply, state the reasons for the behavior, condition of glow, unequal wattage lamps in series.
Requirements, tools and instruments. Multimeter, 1 number. Voltmeter, 0 to 15 volt, 3 numbers. Ammeter, 0 to 500 milliamp, 1 number. Equipment and machines. DC variable source, 0 to 24 volts, 5 amps with output current, and voltage indicator, 1 number. Procedure. Task 1. 3 lamps of 6 volts in series across 18 volts supply, that is unequal wattage. Connect the 3 lamps with ammeter A in series to the variable voltage DC supply source. Connect a MC voltmeter 0 to 15 volt across L, that is low current rating or low wattage bulb. Gradually increase the supply voltage from 0 volts, observing ammeter, voltmeter and lamps L1. Increase the voltage up to 18 volts. Record your observations. Does the lamp L1 fuse? If yes, give your reasons, stating the observation made just before fusing. Open the switch S and reset the supply voltage to 0 volt. Replace the bulb L1. Task 2. With 2 low wattage L1 lamps in parallel as in task 1. Form the circuit as per the diagram. Observe the effect of increasing the supply voltage from 0 to a value that causes 6 volts across low wattage lamps L1. Does the lamp L2 fuse? If yes, give your reasons stating observations made just at the time of L2 fusing. Open the switch S. Replace the lamp L2 and reset the DC source at 0 volt. Increase the supply voltage until a current of 150 milliampere flows in the circuit. Read and record the voltages V1, V2 and V3. Task 3. With 2 L2 lamps in parallel as in task 1. Form the circuit as shown. Gradually increase the supply voltage up to 18 volt. After closing the switch S, observe the voltage V1, current and glow of lamp L1. Does the lamp L1 fuse again? What are the conditions at the time of fusing? Is there any difference in the values as compared with the one in task 1? Give your response. Open the switch S. Replace the fused lamp L1. Reset the supply voltage to 0 volt. Close the switch S and increase the current through the circuit to 100 milliamp. Record the voltages V1, V2 and V3. Task 4. With 3 L1 lamps connected in parallel and the whole in series with 1 lamp L3, 2 L2 lamps in parallel as in task 1. Increase the supply voltage gradually to 18 volt. Observe the lamps, ammeter, and measure the voltage across the lamp group L1, lamps group L2 and L3. Now all the lamps glow with their normal brightness. No lamp fused.
So students, you might have known how to read and interpret data stamped on a given lamp, measure the voltage drop and other important elements.
Exercise 8. Determine the polarity of DC supply.
Dear students, this exercise will help to determine the polarity of the DC current supply. At the end of this exercise, you shall be able to identify the terminals of your MC instrument with respect to polarity, determine the polarity of a DC supply source using a MC voltmeter. Find the polarity of a DC supply with a neon tester.
Requirements. Tools on instruments. Voltmeter 0 to 15 volt, one number. Voltmeter 0 to 300 MC, one number. Multimeter as available or VOA, two numbers. Neon polarity indicator, one number. Equipment and machines. Battery charger with voltmeter as available, one number. DC generator with prime mover as available, one number. Battery lead acid 12 volts, one number. Procedure. Task 1. Checking battery terminals. Connect test leads to the MC voltmeter of 15 volt FSD. Touch one lead from the positive terminal of the voltmeter firmly on one of the terminals of the battery and the other test lead from the negative terminal of the voltmeter on the other terminal of the battery for just a while. Observe the deflection of the pointer of the MC voltmeter.
So students, now you are able to identify the terminals of MC instruments and determine the polarity of the DC supply source.
Exercise 9. Identify the phase and neutral in single-phase AC supply.
In this exercise, you are going to know how to identify the phase, neutral in a single-phase AC supply. At the end of this exercise, you shall be able to test and identify phase and neutral wires with the help of a test lamp, Test and identify phase and neutral wires with the help of a voltmeter. Test and identify phase and neutral wire with the help of a neon tester. Identify phase and neutral cables with the help of color coding.
Requirements: tools and instruments. Test lamp 240 volt 40 watt 1 number. Voltmeter 0 to 300 volt MI 1 number. Neon tester 500 volt 1 number. Procedure: Task 1. Test lamp method. Connect the test lamp 240 volt 40 watts with the supply to test its function. Connect one lead of the test lamp to the earth point. Touch the other lead of the test lamp to any one of the supply terminal. Is the test lamp glowing? If yes, mark the terminal as phase. Go to step 7. Touch both leads of the test lamp across the supply terminals. Mark the other unmarked terminal as neutral if the lamp is glowing. Task 2. Voltmeter method. Connect the voltmeter, that is 300 volt MI, across the supply mains and test its function. Connect one lead of the voltmeter to the earth point. Connect a testing probe to the other terminal of the voltmeter. Task 2. Neon tester. Check the neon tester for its function. Place the testing end of the neon tester in any one of the socket outlet terminals. Touch the other end of the neon tester with your finger. If the neon tester glows, that terminal is phase. Task 3. Color code. Switch off the supply to identified 3-pin 6-amp socket. Open the hinged door of the switchboard. Note down the colors of the cables connected to the terminals from the back of the hinged door. If the black color cable is connected, mark the terminal as neutral. If the color of the cable is red, mark the terminal as phase. If the color of the cable is green, mark the terminal as earth. Close the hinged door and switch on the mains.
So students, mastering this exercise will help to identify the phase and neutral in a single phase AC supply.
Exercise 10. Prepare a piped earth.
This is a very interesting exercise, preparing a pipe earth. At the end of the exercise, you shall be able to dig an air pit, prepare a pipe earth according to BIS specification.
Requirements: tools and instruments. GI die stock with 19 mm and 38 mm dies, 1 set. DE spanners 5 mm to 20 mm, 8 numbers, 1 set. Electric drilling machine 12.5 mm, capacity with 12 mm drill, 1 number. Blow lamp 1 liter with kerosene, 1 number. Crowbar hexagonal 1800 mm long, 1 number. Paura, that is pad, 1 number. Pickaxe, 1 number. Cement mortar tray, 2 numbers. Tongs 300 mm, 1 number. Measuring tape of 5 meter, 1 number. Ladle 2 numbers. Pipe range 50 millimeter, 1 number. Hacksaw with 32 TPI blade, 1 number. Soldering pot, that is melting, 1 number. Procedure: collect GI pipes and the accessories. GI pipe to have a sharp edge at the bottom side and drill the required number so that the distance between the holes shall be as shown. Dig an earth pit. Insert GI wire number 6 SWG through the 12.7 mm dia GI pipe. Insert the lug in the 19 mm dia GI pipe and tighten with the GI nut and check nut and fix the GI funnel with mesh. Place the fabricated pipe in an upright position as shown. And position the pipe. Fill the drum with alternate layers of coke or charcoal and salt. Fill the surrounding outer space of the drum with soil removed from the pit. Pour 3 or 4 buckets of water through the funnel. Prepare the concrete mixture and build the structure as shown.
So students, you might have seen how to prepare a pipe earth with BIS specification.
Finally, related theory for exercise 1. What causes an injury more frequently? A very heavy load or a wrong way of lifting. A work way of lifting something too heavy causes injury. The muscles and joints are strained. This is especially true in the case of injury to the back. Due to a wrong way of lifting is injury to the back. Or the injury is caused as a result of strain only? No. Injuries during lifting and carrying may be caused by tripping over an object and falling, or striking an object with a load. Safety shoes with steel toe caps will protect the feet. Finally, more we obey the rules and safety regulations, we secure our life.
So, my dear students, all the exercises you have seen in basic electrical training, sector electrical, for modular employable skills is for you to learn and understand and to implement in your workplace. So, students, I think you have learned and enjoyed visually. So, all the best for your future.
Hello viewers, welcome to DG Shala. I am Dr. P. Anuradha, Assistant Professor, National Institute of Rural Development, Hyderabad. Today we will be discussing about the e-wallets. E-wallets are the electronic prepaid payment system. By using these wallets, we can purchase and transfer money by using our smartphone. We require internet connection in our phone to use the wallets. An individual account is required to be linked to the digital wallet to load money in it. There are many e-wallets available in the App Store. Today, we will discuss about one such app called SBI Buddy. In order